Hi there. We're going to look at simple to complex Lewis structures and the most tested ones and also easy ways as well. Now, look at carbon monoxide. So carbon 4, oxygen 6, total of 10. You put a bond between carbon and oxygen and then add the electrons, total of 10, right? So that's what we do. So there's not much of a pattern to learn here. But we know we have a carbon to oxygen triple bond and each carbon and oxygen has a lone pair. So that kind of memorization, right? Not much you can do about it. Now look at these two molecules, right? So you're starting to see patterns, CH4 and water. So the CH4 has total of 4 plus 4, 8 electrons, and then water has 2 plus 6, 8 electrons. Now, center one is carbon. You put the carbon in the middle, put 4 bonds, and that's it for CH4. And for water, oxygen in the middle, 2 sticks for the each hydrogen, and then there's leftover 4 electrons and put it in the middle, right? So that's how we do it. But there is not much of a pattern or memorization or tactics there, right? All we did is satisfy the octet and put all the total electrons. But this is what you want to do. So you want to know the third period quite well. So that goes from 1 to the 8th period. That would be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? And also be aware of the lone valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8, right? So you just learn to put the valence electrons the way I'm doing here. And now you have the valence and also just not only how to draw it and also remember the numbers 1, 2, 3 for lithium, beryllium, boron, and then for the carbon, nitrogen, oxygen 4, 5, 6, and then fluorine 7. So we are not going to do much with neon, right? Even though it's 8. Now also you're going to remember below carbon, silicon, below nitrogen, phosphorus and arsenic, below oxygen, sulfur, selenium, and below fluorine, chlorine, bromine, iodine. Remember those blue ones. Keep an eye because your prof going to ask questions based on those, but he's going to teach only the top lithium to fluorine, right? So we're going to learn side by side. That's the tactic. That's one of the perfectly worked tactics for the last 20 years. So let's see how it goes. So rules. So there's many rules, but just remember, take the total number of electrons by counting those valence electrons above. And also remember, if you have a plus sign, that's a loss of one electron. If you have a negative, it's an extra electron gain. So that's it. Now, choose the center atom. That's a tough one because you have to choose the least electronegativity and also least number prevalence. It's 1 against 3 and so on. It's hard to decide. I'll show you. Mostly it works. Now, also the satisfy the octet rule for each atom by moving pairs of electrons to make either double bonds or triple bonds where necessary. Where necessary only. You try to satisfy octet first, right? If not, you make it double or triple. So that's how you do it. So let's look at the simple ones. Simple ones are hydrogen, and let me take fluorine and oxygen and nitrogen. So it's going to increase a little bit of the complexity. So total electrons, hydrogen has 2 times 1, 2. Fluorine has 7 times 2, 14. Oxygen has 6 times 2, 12. And nitrogen has 14 total, right? Sorry, 10 total, right? Yes, total electrons are right. So you want to be really just look at the periodic table and fill that one, right? Look at the hydrogen. Each electron combine because it's a covalent and it's a stick in the middle and it's called the duet. So that's the only time you're going to see it. Look at fluorine. 7 electrons each fluorine atom. Now you have to have a bond in the middle. You put the bond and you put the electrons. Now look what happens is each fluorine has an octet. And duet to octet, that's the major point. Let's go to oxygen. Oxygen each has 6 electrons. Now you're going to have a bond in the middle anyway, right? Now each oxygen has only 7 electrons. We are trying to satisfy octet happiness. We are not there. So we put 1 electron from each side. Now you make 2 bonds in the middle and see 4 electrons each side, 2 lone pairs each octet, everybody happy. That's what you're trying to do. Do the same thing for nitrogen. Take nitrogen. Each atom has 5 electrons in the valence, right? Now we're going to put the 5 and put a stick in the middle, right? Now we're going to put a second one just to see whether it satisfies. Now what happens? There's no octet to each nitrogen. You put two more in the middle, triple bond in the middle, and each has a lone pair. Voila, each nitrogen is octet. So that's how you go from simple to complex. Look at this one. Try to learn the patterns side by side. H3O plus hydronium and NH4 plus. Plus is a lost electron. 3 plus 6 minus 1 is 8. And then you put the oxygen in the middle, 3 sticks for each hydrogen. You have to have bonds. Now you have leftover pair of electrons, put it in the oxygen, right? The plus is in a square bracket outside. That's how you show a charge. Look at ammonium. So 5 electrons from the nitrogen, 4 electrons from the hydrogen. So plus is a minus 1, 8 electrons. Nitrogen in the center, 4 hydrogens stick to each side, positive charge outside the square brackets. That's how side by side you want to do those. So this one is NO2 and NO2 plus. Popular question for some of the professors, right? Now look at this one. Nitrogen 5, oxygen 2 is 12, 6 plus 6, 17. And this one is actually plus charge, reduce 1, it's 16. Now first, nitrogen in the middle and 2 oxygens each side. Each needs a bond at least. Now, start from one corner. Put the octet to each oxygen first because there's 12 electrons, right? Now we have to see what happens. There's one electron left. Put it in the middle. Now we are trying to make octet, but oxygens are good, but the nitrogen is not. Now I can put each from each side 2 electrons. But see what happens. Nitrogen goes beyond 8. Nitrogen can never do that. So therefore only one goes into the bond. So you get oxygen and one bond nitrogen, one dot on the head, and then double bond oxygen. So now oxygens are octet, nitrogen is not. Doesn't matter, but nitrogen cannot have 9. Remember that. Now you're going to use that one to learn the next one. You see there's 16 electrons. Now you get the bottom structure and get rid of that electron that we don't need, and then you put a lone pair into the center. Now double bond to each side. Oxygens are happy, 4 electrons each oxygen, double bonds, and center nitrogen has 2 double bonds. Everybody is octet. Look at this pair, NO and NO plus. You see, make the NO perfectly and then just adopt into the NO plus. So nitrogen and oxygen is one bond, and then there's 6 electrons around oxygen, and nitrogen has 3 more, right? So now oxygen is already octet, right? You can push into the middle just to make happy the nitrogen. But now oxygen is perfectly fine, but nitrogen has only 7. We are not happy. That's the problem with odd electron systems, right? Now we fix the problem in the NO plus because you get rid of the crazy electron, right? Now you see that now you can move a pair of electrons from the oxygen to the middle, and you have a triple bond oxygen, lone pair on the oxygen, lone pair on the nitrogen. See, when it's when it's even, they are perfect, right? Now let's look at these crazy pineapples, right? So N3 minus, and it's from 16 electrons total because of the negative gives you 1 electron. Sodium has 0, chloride has 7 plus 1, calcium is 0, oxygen has 6 plus 2, 8, right? Here in 3, you just stick into a line because there's no particular center, right? And then in these ones, what do? You actually satisfy octet from one end to go to the other end as long as you have electrons, right? So that's what I did the top one. But you may do this one. N, double bond N, double bond N, and then you try to fill the electrons where it is. That would work though. They both are correct. Now sodium plus no electrons and chloride minus has 8 electrons, and oxide minus 2 has 8 electrons, right? Now let's do another pineapple. So C2H6, and you have to put 2 carbons together, and we know hydrogens are terminals. You put hydrogens all over the place. Basically, carbon can have 4 bonds, right? Now look at this one. Carbon to carbon connected, only 2 hydrogens, be symmetric. Put it to each corner, and now you left over 2 pair electrons on each carbon, and make a double bond and make a triple bond and see what happens. Look at this one. Double bond is not good, but triple bond is good. Each carbon is octet. That's how you do it. Thank you.